The vertices of quadrilateral KAIT are K, which is 0, 0, A, which is A0, I, which is A plus BC, and T, which is BC. Use coordinate geometry to prove that quadrilateral KAIT is a parallelogram. Well, there's several ways that you could prove something is a parallelogram, but probably the easiest way to do it is to show that you have two opposite sides are congruent. Two pairs of opposite sides are congruent. So if I were to imagine KA and IT, so that's kind of what I have to do. I have to do that. I have to show two pairs of opposite sides are congruent. So number one, I have to show that KA is congruent to IT. When I'm done that, I have to do AI and KT are congruent. Okay, so again, if you're like, I don't see it, I don't see the picture. Look, there's a picture, KAIT. It has to give you whatever order it's in. So I have to show KA and IT, and then I have to show AI and KT. That's what I have to do, so that's what I'm going to do. Okay, so I need to show that Ka and It are congruent. So the way we do that is we use the distance formula. Okay, so let's write out the distance formula down here. The distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All right, so if I were looking at KA, okay, we'll do this all in separate parts. KA, I would say that the distance equals, let's let U be x sub 2, y sub 2, and let's let U be x sub 1, y sub 1. In fact, I'll write that out just once. I'll do this once, and then I probably won't write it out again because otherwise it'll get sloppy. 1, 1, 1, 1, you're supposed to be 1. All right, x sub 2 minus x sub 1 is going to be a minus 0 squared plus 0 minus 0, which is 0 squared. So let me get rid of this extra. Okay. That gets me a minus 0 squared. So I need my square root still. I don't know why I got rid of my square root. So square root a minus 0 is just going to be a squared plus 0 squared is just 0. So the square root of a squared is just a. So the distance of Ka is just a. All right, I can handle that. So the distance of IT has to be a as well. So IT, distance formula. Okay, let's let U be our 2's and U be our 1's. So x sub 2 minus x sub 1 is going to be B minus A plus B. B minus, now be careful. If I'm subtracting both A and B, it's going to be A minus B. I know that looks weird, but trust me. Plus C minus C, which is 0, so 0 squared. B minus B cancels out, giving me A squared. Plus 0 is just A squared. And again, the square root of A squared is A. So we did it. So since Ka is A and IT is A, Ka is IT. Thing number 1 proved. Now, Ka is IT. Now I need to show AI is KT. So I'm going to say show AI is KT. AI, artificial intelligence, or Allen Iverson, my second favorite Sixer of all time. All right. AI. Let's get rid of all this mess up here. I'm looking at AI, so let's let u be the ones and u be the twos. So x sub 2 is a plus b minus x sub 1 is a squared plus c minus 0, which is just c squared. A minus a cancel out, and that gives me just b squared plus c squared. Now let's not try to simplify that, because my goal is to make sure that kt is the same thing. So who cares if it's simplified? Who cares? kt, that distance, big square root. So let's let u be my twos and u be my ones. So I have a feeling this one's going to be a lot friendlier because of that double zero. B minus 0 plus c minus 0 is going to be b minus 0 is just b, so b squared. And c minus 0 is c, so c squared. So we just showed that AI is KT, which means Kate is a parallelogram. And I believe the name of that theorem is the opposite sides something. I don't know. But since two pairs of opposite sides are congruent, it's going to be parallel. And there's a name to that theorem. It's just escaping me because right now I'm recording this at 10:15 p.m. But that's how you do it. We proved it. All right. Coordinate geometry proofs. You just have to do the math. And a lot of times the math is fun because things disappear. That's what happened. Fun.